Welcome to a lesson with Dr. Powell. Let's talk about something called piecewise defined functions. But first, let's take a look at how we can think about a function's domain. I mean, normally we think about functions as, being, if we give a formula here, any x value that makes the formula work, we say works in the domain and we include it in the graph. But we can actually do differently than that. Suppose we have something like x plus 2. This is a nice graph, or has a nice graph. And you could think of it as the graph of y equals x shifted up 2, or you could think of it as being shifted 2 to the left, either way, with the slope of 1. However you think of it, it looks something like this, or you could just think y-intercept 2, slope 1, however you want to. Anyhow, we get the graph. Looks great. But what if we were to put a little comma here and say x is bigger than -1? We've just changed the graph. When we put a comma here, what we're doing is we're adding in a condition that we want to hold. We're imposing a condition on what the inputs can be. So we're not just going to take any x value that makes these operations work, but we're going to impose a restriction, a self-imposed restriction for this function. And we do that by just putting a comma and an extra condition that we're just putting in there, even though this expression would work for other values. We don't care. We're just going to restrict it. So here, redo that. That means that we don't want any x values to show up in the picture that are less than -1 or even -1, because we didn't say equal, we just said greater than. So we put an open circle here at the x value of -1. Okay, so that's how we graph that. Now, what if we had another function, and I'll just use a y for this one, and suppose that this function was something like negative x -1. All right, let's look at that graph. So this function has a nice graph. There's a slope of -1 and a y-intercept of -1. So it looks something like this. Now let's impose a restriction on it. Comma x, this time let's let it be x is less than or equal to -1. Okay, so this graph right here corresponds to this one, but then we're going to impose a condition. Well, when we graph it, we have to respect this. We don't want any x values showing up that don't satisfy this. So x is less than or equal to -1. Okay, we have to get rid of anything on this graph that's not less than or equal to -1. So we get rid of that. And that means we have to just draw this up to that point, up to x equals -1. So we have this graph right here and this graph drawn right here. We have this one for this one and this one for this one. Now, what if you were just to look at this picture? I've drawn two functions, but I've restricted their domains in such a way that when I look at this picture, look what happens. I draw a vertical line. It only crosses the whole picture once, even though I have two things drawn, right? Only once. Even when I draw it right here through open circle and closed circle, it only hits once. Wait a minute. The combined picture in totality actually makes one function if I put these two together. And that's because I restricted the domain pieces in just the right way so the vertical line test would always work. And it made a function. We call this a piecewise defined function because it's defined differently on different pieces. The different pieces are these two pieces of the domain, in fact. So of the x-axis, if you will. One piece that goes this way and one piece that goes this way, and they're disjoint from each other. They don't overlap. So what we could do, since this makes one function, let's emphasize that instead of writing this, where we have two functions written like this, y equals and y equals, let's just make one y equals. So we kind of put these together and we write something like this. Put a big curly brace and say y equals. To emphasize, it's just one function from this splitting right here. So it's just one function. We could even replace that y with an f of x. This is what you call a piecewise defined function. We'll look at some more examples in some more videos. Thanks for watching.